In this video, we're going to talk a little bit about the common package. This is a set of utility functions that's intended to make up for some things that are missing in base R. So the first thing we'll do is load up the common package here. And everyone knows that in base R, if you want to create a vector of values, you use this C function right here. And what that gives you is this quoted vector. And the first function we're going to talk about in the common package is this v function. And what this allows you to do is create a quoted vector from an unquoted vector. So here I have the unquoted values 1, 2, 3, same as we had above, but unquoted. And the v function will quote them. So the values come in unquoted and they go out quoted. And as a result, you get the exact same vector of values. And this is useful in several cases, most importantly when you want to pass in a vector of quoted values to a function, but you don't want to type the quotes. So this function allows you to pass in a list of variables to proc_freq and get results without having to quote those variable names. And so that is the v function. Next, we'll look at this labels function. Up here, I copied the empty cars dataset into this variable dat, and we just want to look at that. You can see on this dataset that there's no labels on the variable names. I can assign labels with the labels function. You just wrap that data frame in the labels function, and then you pass in a list of labels that you want to assign to that data frame. And when you now view them, you get labels. And that function works in reverse. If you want to get the labels associated with the data frame, you can pull them off just by calling that function and looking at all the labels that have now been assigned, which is right here. So we saw those labels on the data frame a second ago, and we know they're there. One unusual behavior about base R is when you subset a data frame using subset brackets or subset function. There's a lot of functions that when you use them in base R will strip off the labels. And so I just did a little subset on that dat data frame. And if you notice, now the labels are gone. There's an empty list instead of a list of labels. And this copy attributes function can restore attributes to a data frame. The labels are an attribute. And what I can do is pass the original data frame and this new data frame that I created, the subsetted data frame. And what it'll do is match up the columns from the original data frame to the subset data frame and assign any attributes from the first data frame to the second data frame, and then return that here. And so now when I look at so I only pulled off 3 columns here in my subset, and those 3 columns now have the labels restored from the original data frame. So even though there were fewer columns, it was able to map those and give me the correct labels. So that's a useful function when your base R functions drop your attributes. Here's another function in the common package. It's called changed. And what this does is identify when a value in a column has changed. And so if I run this, what I'm getting here is this AM column, which has these values. And what I'm going to do is add a new column to that dat2 subset data frame of the values in AM that have changed. So here's my AM values. And you can see for every time that AM changed, I get a true. So the first time comes out true, and then when it flips to 0, I get a true, and then when it flips back to 1, I get another true. So that is a useful function when you're trying to identify breaks or groups in your data. Here's a useful function. This is syspath, and what this gives you is the path of the currently open program in RStudio or the currently executing program in RStudio. And it's amazing that this function does not exist in base R. In most languages, there's an equivalent function that you can get the path of the currently executing program. In base R, there is not, and so this syspath function can help you get it. Here's another function. In base R, it's a little bit inconvenient to paste things together. Most languages have a concatenation operator instead of a concatenation function. R has a concatenation function. Paste 0 or paste adds the space in between. And so here I just pasted my hello and world together to get hello world. This %p% is an operator that does the exact same thing, and it's just a little bit more convenient to use instead of this function. I've only got 3 characters to type here instead of all this stuff. There's another operator in this package, %eq%. And before we look at that, just want to remind yourself of how comparisons work in R. If you do 2 double equals 2 in base R here, you're going to get a true value. If you do 2 equals 3, you'll get a false value. If you do 2 equals NA, you'll get an NA. If you do 2 equals null, you get a logical 0. Normally in base R, you can't compare either NA or null to a value. They don't come out either true or false. And that sometimes causes trouble, especially in conditions. So what you end up having to do is wrap that condition in another condition that first checks for NA or null, and then if there is no NA or null, then go do your comparison. What this %eq% does is will give you a true or false kind of no matter what happens. If I get an equivalent value, I get a true. If I get an unequivalent value, I get a false. If I have an NA value, I have a false. And if I have a null value, it's a false. So it basically gives you a true or false for any kind of comparison, which is quite convenient to avoid wrapping your conditions in more conditions to check for these 2 special values. Here's a base R function called list.files, and this searches for files in your file system. You can set a pattern and set whether or not you want it to look in subfolders. In this case, I'm looking for this setup.r file, and I want to look in all the subfolders. But what happens here is I get a character 0, meaning it didn't find anything with this particular pattern. And the reason it didn't find anything is because that file is actually up 2 levels. So the file I'm looking for is above the current working directory. So what is the base R function to search up instead of down? Well, there is none, and that is why this file find in the common package exists. You can search up or down and also control the scope of that search. So here I want to look up 3 levels and down 0 levels. And now I get a result. It's telling me that it's at this location in the file system. And there's an exactly equivalent function for directories. So here's the base R list directories function. This has got recursive equals true, and you can see there's a bunch of hidden directories here. It looks like it's created by RStudio. But when I do dir find from the common package, again, I can control the scope, look up or down. And here I restricted the recursive search down to only one directory and then also allowed it to go up 2 directories. So now I get this list results instead of this big list of hidden directories. One last set of examples here is involving superscripts, subscripts, and symbols. There's a function here, r-sassy for superscript. And what this does is turn a numeric or character value into a superscript value. So here's the number 1, and the superscript function converted that to a superscript 1 here in the console. And same with 2 and 3. I can get superscript characters out of these regular characters. And that's useful when you're creating footnotes or something in a document where you need to call it out. And so here's the ABC superscripts. There's an equivalent function for subscripts. There's the A. Now you notice the B comes back with a question mark. And that's because there is no UTF-8 subscript character for a B. And the subscripts are generally not very well supported in UTF-8. So you may get a few of these question marks if you're trying to create these subscripts with this function, and that means they just don't exist in UTF-8. Now notice the X was supported, and that's because what's generally supported in UTF-8 is subscripts that are commonly used in mathematical equations, and so they put the X in but not the B. Here's one last useful function, the symbol function, and what this can give you back is UTF characters for special symbols. Here's a special symbol for the registered symbol, and all you do is pass in this little keyword reg and you get back the symbol. And here's a trademark symbol, less than or equal to, greater than or equal to, not equal to. So this is very useful when you're trying to create a document that has these special symbols. You can use these programmatically in a way that might be difficult otherwise. Here's some Greek letters, and here's some special symbols very frequently used for footnote indicators. And this symbol function can combine different values. So here, like, my company is the name of my company, and then the reg is the symbol keyword. And so you can see what it did is scan the input string for any symbol keywords, and if it found it, it'll make that replacement. But anything that was not a symbol keyword just leaves it alone. So that's how you can easily append a symbol onto another string without having to paste them. And this is quite useful if you're creating little equations here. So here's a couple equations. This first one is quite simple. The second one is more complicated. And so that's a nice way to do it if you're trying to create equations in your text. And that is a quick overview of some of the major functions from the Common package.